Okay, so trig solving, and this is going to be using the Casio FX CG50. Try and get the most out of that calculator. So we're going to go through kind of every different type for the AS kind of questions. So we won't be using any second year trig identities here, but a lot of the solving methods are the same. So we've got solve for the following equations, give you answers to 3 sig figs where appropriate in the intervals indicated. So for this one, I'm just going to work through A, and then the other ones I'll pop the answers up. So we've got sin x equals minus root 3 over 2 in the interval minus 180 to 540. Okay. So if we grab our CG50, see I've already been doing some stuff on it. Let's delete these out of the way. Something worth checking early on is that you are in degrees. Obviously I'm here. So y1 we'll put sin x, and in y2 we'll put the number it equals. So for these, before we can put it in our calculator, we always need trig equals number. So for b, you have to do a bit of rearranging first. It's just divided by 2. So the number we've got equal to is minus root 3 over 2. So minus root 3 over 2. Now, next thing to check is our view window. So we need to make sure that it's only going to give us the answers in the range that it wants. So go shift, view window. So do that again. Shift, view window. So shift F3. So we want our x min to be the same as this bottom end of our interval. So x min needs to be this minus 180. It needs to match. So minus 180. And x max wants to be 540. I would make your y min, y max minus 2 to 2. It just gives a nice, easy view, especially for sine and cos. For things like f, where its tan is 2.9, you have to extend that range a bit to include the 2.9. So then we can press exe to leave that. And now we are ready to draw and get our results. So if we F6 to draw, and we can press F5 to G-solve, and then we want intersection. So look, there's loads of things you can find here. We want where these two intersect, where sin x equals minus root 3 over 2. So F5 again. So we get minus 120, minus 60. I'll have to write these down. So we've got x is minus 120, minus 60. Let me grab the calculator back for more answers. Oh, not teams, sorry. $240, 300. And that's done. So I'll give you the start for B. So for B you need to divide by that 2 first, so you get sin x equals minus 0.15, and then follow the same procedure. Answers are here. Okay. Now, these are the ones where it's a bit more interesting. There's a little bit of an extra step to do before we can get to our calculator, and a bit of an extra step at the end. So the thing to notice is that inside my sine function, I've got sine of 4 theta. Now my range is just theta. They don't match, and I need them to. So first thing we need to do is make what's inside that range match what's inside my sine, cos, or tan. So I'm going to multiply it by 4. So 4 times 0, 4 theta, 4 times 360. So 0, 4 theta, and let's not make a silly error. 4 times 360, 4 times 360, 1440. And now it's the same thing in our calculator. So sine 4 theta equals 0. Now, even though that says sine 4 theta, we're still just going to have x, just sine x. Because to get the marks, we need these 4 theta values. So we g-solve, need to change my view window, sorry. 0 to 1440. G-solve, intersect, so I've got 0, 180, 360, and I'm kind of aware, if I keep clicking through those, it's just going to keep going up in 180s, so 0, 180, 360, 4, 5, 40, 720, 900, 1080, 1260, 1440. And there what you get if you just scroll through the answers here. We just go 360, 540, 720, 900, 1080, 1260, 1440. Now they are 4 theta values. Because we changed our view window, it's given us 4 theta values. So what we need to do is divide each of those by 4. So we're going to get 0, 45, 90, let's not do anything silly, 135, 180, 225, 270, 315, 360. Okay. I will say, as a quick key point, for F, because it is a minus and we're looking at inequalities, we do need to be careful, because when we times through by the -1, so we go from theta 360, and we make it minus theta in the middle, it's going to flip over those inequalities. Now in there we could have more complicated things. Let me grab a black pen quickly. We could have things like sine of 2 theta plus 30, and we would double our range, so make it in this case 720 to 0, and then add 30. So do your multiplication, then your addition, and at the end just solve it like a normal equation. So 2 theta plus 30 would equal something. You would minus 30 and then divide by 2, just like a normal linear equation. Okay. The rest there are yours to have a go at, and the answers are here. Okay. Now, here we have some where we've got a bit of an extra step before we get to our final answer. So we've got √3 sine x equals cos x. Now these are all following this kind of same pattern where we need to be aware that tan theta is sine over cos. So if we look at this first one, we need to divide by cos, so we get sine over cos. And remember, that's going to equal 1. Common mistake is to divide by cos on both sides there and get to 0. So we've got √3 tan theta is 1. So tan theta is 1 over √3. No editing the range needed. Theta and theta match already. So let's grab our calculator to get some theta values. So we want tan x is 1 over √3, which is the same as √3 over 3. If you worked it out in a calculator, you get √3 over 3. Didn't fix my view window, So 0 up to 360. G-solve, intersect 30 and 210. Okay. I will do B to show you it with more working, but you can have a pause and a chance to do it yourself. Okay. So this time, before we can start dividing by cos, we should move it over, then divide by it. So we get tan is minus 1. And I'll grab my calculator again. So tan minus 1, G-solve, intersect 135 and 315. Here are the answers to the rest. So, now for the slightly more complicated ones. So now we've got squared going in everywhere. And I'm going to do A and I think F on this. So, we've got 4 cos squared equals 1. Now, before we can do anything, we need trig equals number. So let's divide by that 4. So cos squared is 1 over 4. Now, to put it in our calculator, we need trig equals number, not trig squared equals number. So now we need to square root. And the easiest thing here is to go, well, cos is square root of a quarter, which is a half. But you've lost something. You've lost the other set of answers. We've lost the fact that it could be minus a half. So when we square root, we get plus and minus. Okay. Now what we have to do is put each of these in our calculator. Theta does match the theta in the question. So we can say cos x is a half. My view window, is it good? 0, 360, 0, 360. G-solve intersect 60 and 300. Minus a half. G-solve intersect 120 and 240. Okay. So, I won't do B next, I'll do one of the proper quadratic ones. Let's do E. So we've got 2 cos squared minus 5 cos plus 2. Now this is an optional step. I'm going to swap out cos for something else. What that's going to do is make the quadratic look a bit easier to solve. It's going to make it just look a bit more familiar. So you don't have to do it, and you'll get all the marks without it. I would always make cos C. Don't make it x, y, or theta, because that's really confusing and kind of not true. If you said cos theta is theta, then there's a solution to that that's kind of unique. Whereas if you make it something random like C or alpha if you really want, it's going to keep out of the way. So we get 2c squared minus 5c plus 2 is 0. We can factorise that quadratic. So we want minus 2 minus 1, I think. So we get c is a half, or c is 2. Remember, c is cos. Now this one has got no solutions, because cos has got this max at 1 and min at minus 1. And cos theta is a half, Our range is the same, the theta still matches, so I can kind of just remember what my answers were from before. Okay. So, here are the answers to the other ones. Note for G, you do in fact need to change the range as well, which is how there's so many solutions. Okay. Now for the final kind of version of this question, we've got solve for theta in the interval 0 to 180, 3 sig figs when they're not exact, these things. Now, the issue here, if we look at this first one, we've got sine squareds, causes, sine squareds and causes. So what we're going to need to do is make the quadratic, the squared term, match that non-squared term. And we can only change the squared stuff. So what we're going to use is the fact that cos squared plus sine squared is 1, meaning sine squared is 1 minus cos squared. So we can put that in straight away. 1 minus cos squared minus cos is 3 minus 2 cos. So we've got 4, 1 minus cos squared minus cos is 3 minus 2 cos. We'll need to expand that, so 4 minus 4 cos squared minus 4 cos is 3 minus 2 cos. 0 is 4 cos squared plus 2 cos minus 1. I won't do the cos trick this time, so you can see how that would look, but you could swap the coses for c's if it makes life easier. Let's see if that factorises quickly. Oh, it doesn't. That's not got a nice solution, so I have to use a quadratic formula for this one. Remember that we will need to write out the quadratic formula to make sure we get our method mark for attempting to solve the quadratic. So 4ac over 2a, and that's going to give us two values for cos. I will grab the calculator to show you that working. So if I go on to my equation mode, polynomial is your x to power plus x to power plus x to power, where the powers are numbers, whole numbers. Degree is the highest power of x we've got, or cos, so we've got a 2. So we've got 4 cos squareds plus 2 coses minus 1 on the end. So it comes out as minus 1 plus root 5 over 4 and minus 1 minus root 5 over 4. And we can see they're both okay answers. So minus 1 plus root 5 over 4 minus 1 minus root 5 over 4. We don't need to change our range. The thetas match. So we go back into our graph mode. Do note that it's graph you want to be in, not dynagraph. So cos x is fraction minus 1 plus root 5 all over 4. G-solve intersect 72. Oh, 72. That's really nice. And 288. Wow. How have I put that up? 288. I didn't change my range. Apologies. That's how easy it is to make mistakes. And the way I spotted that was that 272, or whatever that number was too big. Yeah, 72 only. So now make this a minus. And we get 144. Really common in these quadratic questions to get one of the solutions doesn't work. Not every time, but it's quite common. Okay. there are answers to the other ones. So there's no solutions to that one, that's interesting. And that is trig solving.